This video is part of an online course of Calculus 1 and I'm going to talk about trigonometric functions. So what are they? Basically, trigonometric functions relate the ratios of two sides of a right triangle. Right triangle. Okay, what it means is that let me consider a right triangle with sides A, B, and C. Then we have what? Let me graph a right triangle first. Okay, this is the last side. Okay, this is a right triangle with 90 degrees in here. And then let me consider A, B, and C as the side of that. And then let's consider X as this angle in here. Okay, so what is sine of X? Sine of X is a trigonometric function, and sine of X here would be B over the hypotenuse. So I have B over C in here. Then we have cosine of X, which is equal to A cosine would be A over C. Another trigonometric function is tan of X. Tan of X would be sine of X over cosine of X. Okay, it has its identity, but if you want to use the right triangle to write this, it would be B over A. And cotan of X is equal to A over B. A over B. So tan would be B over A, cotan would be A over B. Okay, let me give you one example. Assume that we have this right triangle in here. So it is 90 degrees. This is X, and these two sides are 1. So basically, by Pythagorean theorem, the hypotenuse would be 1 square plus 1 square, which would be square root of 2. Okay, now X here, since this is 1, X here would be pi over 4. And based on that, sine of pi over 4, sine would be 1 over root 2, the hypotenuse, 1 over root 2. Then cosine of pi over 4 is equal to 1 over root 2 again, so this 1 over root 2. And then if we want to write tan, actually let me write it in here, tan of pi over 4 is equal to what? It's equal to B over A, which would be 1 over 1, which is 1. And cotan of pi over 4 is also 1, because you just need to flip tan to get cotan. It's 1 over 1. Okay, let me give you another example. I'm gonna have this right triangle in here. Okay, so this is 90 degrees. Let's put this one 30 degrees, and so this one would be 60 degrees. Okay, and I'm gonna have root 3 as this side and then 1 as this side. Then the hypotenuse would be equal to square root of this side square, which would be 3, plus this side square, which would be 1 square. And so this is square root of 4, which is equal to 2. Now let's consider 30 degrees, which would be equal to pi over 6. And then sine of pi over 6 Okay, so sine of pi over 6, it would be the front side, which would be root 3, over, oops, sorry, 30 degree would be here, right? So the sine of 30 degrees, it would be the front side, which would be 1 over 2. And then I have cosine of pi over 6. Cosine of that would be root 3 over 2. And tan of pi over 6, tan, it would be this over that, 1 over root 3, and cotan would be the flip of it, root 3. Now, if I consider 60 degrees, which is pi over 3, okay, 60 degrees would be here, okay? Now, for writing the sine of that would be the front over hypotenuse. So, sine of pi over 3 would be root 3 over 2, which is equal to cosine of pi over 6. So this is sine of pi over 3. And then cosine of pi over 3 would be adjacent side over hypotenuse. So it would be 1 over 2, which equals to sine of pi over 6. So this is cosine of pi over 3. And based on that, if I divide these two together, I get that tan of pi over 3, which is equal to sine over cosine, is equal to 1 over root 3. Okay? I'm going to give you a table for the sine, cosine, and tan for different angles. You don't need to graph this right triangle every time that you want to write this. So sine of x, cosine of x, and tan of x. Okay, and what are the x's? I'm gonna have pi over 6. Pi over 6, sine of that would be 1 over 2, cosine root 3 over 2, and tan is just need to divide these two together, so it is 1 over root 3. Then I'm gonna have pi over 4. Pi over 4 is 1 over root 2. We calculate this one in this example actually. And then 1 over root 2, and then tan would be 1. And then let's go over pi over 3, 60 degrees as well, which is root 3 over 2, 1 over 2, and divide these two, root 3. I suggest that every one of you memorize this table, basically memorize sine and cosine for these 3 angles, because they are very useful and we're gonna need them a lot during the course. We can calculate them using this technique, but every time if you want to calculate that, it would be hard. So I suggest that you memorize sine and cosine, and remember that for tan, just divide these two for these 3 angles. Okay, so let's go to trigonometric identities.